I had everything all ready to go, and now I'm wondering where. Oh no, it's still here. Okay.
Good.
So lesson 7, which was kind of a review, but then kind of not. I was confused at first. And then once I got going, I figured out what I was doing. So, how about you guys on part 1? Did you have any issues?
I'm good.
Okay.
You know, I had forgotten how to get the percentile, but I just had to go back and review. It made me realize all the things that I didn't remember.
Mm-hmm.
Yeah. I feel like every lesson I'm starting over and I forget what happened before. So we'll see how that goes on the test.
Yeah, I have to figure out what words are asking for which formula. I think is what I learned from this lesson.
Mm-hmm.
Right. Yeah, definitely by the end I was like, oh, what is the probability? Oh, that means I need to get the area up at the top of the applet. And finally I feel like I have that stuck in my brain.
Right.
Okay, so let's go to part 2 then. Am I in the right one? Preparation assignment. Okay, so part 2, I'll start it. Suppose Pair Computing sold an average of new 45 phones per minute in 2011. Yes, that means they sold 23,652,000 P phones in 2011 with a standard deviation of sigma, which equals 10. And they looked at their P phone sales data and determined that they are normally distributed. So, samples of size n equals 4 are taken from the normally distributed 2011 sales. What is the shape of the distribution? And that, I think we all know, is normal because it says it's normally distributed, right?
Yeah.
Mm-hmm.
And then number 5, a sample size of 40 are taken from the normally distributed 2011 sales data. What is the shape of the distribution of X bar? So again, we know it's normal because the sample size is large. Okay, and the sample size of 4 is taken from the normally distributed 2011 sales data. What is the probability that the observed X bar is less than 40? And I have C notes, number 6. So this is when we get into our real work, and we found the Z-score first, right?
Mm-hmm.
And plug that into the applet because it asked for probability. And I got 0.1587, which would actually be 0.159, right?
Lee's asking if our mic is working.
Oh,
no.
I know. I guess I haven't heard her in a while.
Yeah, she just messaged. It's not working again.
Let's see.
Nope.
She hang up again?
Yeah, I just kept getting this like it was messages were coming in. I was like, what is going on? And so I looked, and it was her saying, is my mic working? So. Right. How did you get us on that one, Sarah? That was like super easy. Like I just got like a call list coming in as opposed to like having to follow a link.
So at the very beginning, there's a page that says, do you want to make this public or private? And then in that spot, you can invite people. I didn't invite anybody. I just said start broadcast, and then it'll prompt you after you've started it to add guests, and that's all I did.
Oh,
so ignore that first prompt to invite people. Just don't put anybody, because that's just like an invitation. I think that's what was screwing us up. Yeah.
Oh, that's because you're inviting them. That's when we get the email. Are you going? And you just say yes or no.
Yeah, exactly.
Got it.
Ignore that.
But it's missing the who can watch it.
Yes. So just wait till the second time where you can actually invite people right when you open it up, and I just did that instead.
To come and listen. Got it.
Does it have to be public so that our teacher can see it
Yeah, I don't know.
if he wants.
Maybe
He can ask. He can say,
There's-
that doesn't work.
there's
No, you
public-
make it private because you give him the link to watch it.
Yes, exactly. So I think as long as he has a link, but just on that screen, you can make it private. Just don't put anybody's email address.
Okay.
So that's why you have to give him the link. You make it private, and then if you give him the link, then he can watch it, I think, is how it works.
Right, I think
Public
so.
means that anyone who wants can watch it. They don't need
Yeah,
a
as
link.
long as they have a link. Yeah.
Because if you go into YouTube to like watch some of our videos, they'll be like the next ones showing will be other people from other classes or other groups that like their videos.
Right.
Did we lose Lee altogether?
Oh,
There she is.
I'm back.
Muted. There you are. Unmute.
Can you hear me now?
Yeah.
I'm sorry. I was like fidgeting with my computer trying to figure it all out. So you don't have to go about how you got your answers, but can you just summarize, go over, make sure we're all
We were
good?
waiting.
Oh, you're so nice. I know, but I didn't hear anything before you guys caught on that I didn't have a mic.
Oh no.
Oh, you couldn't hear? Wasn't the
Well, I could hear, but I was just distracted because I was fidgeting. with
okay.
We just did 4 and 5 that they were both normal.
Oh, great. Okay.
Whoops, that's homework.
You just read 6, Heather.
Okay. Thank
Okay, yeah. So we had normal, and then 6. We found the z-score, and because it asked for the probability, plugged that into the applet, and we got 0.159. I did 4 numbers, but 0.1587. But
Yeah.
Right, and I think it's important on that one to note that we're looking for the observed data of x is less than 40, so we make sure that we take the data on the applet that's less than, because sometimes it'll be greater
I
than.
did that wrong. I mean, I had the wrong answer, and then I went back and realized that
Yeah.
was because I used the wrong thing. So that's going to
Me
be
too.
tough on the test.
Yes, just make sure you pay attention to that detail.
that's right, less than or greater than, yeah.
Mm-hmm.
And then it's the sample, so you have to do the on the bottom. You have to do the sigma
Divided by
the
sample.
square root of
Yeah.
Yeah, that's another thing I was having trouble with. Like, I think it was in the homework where there was one, and it didn't have a sample size, and I'm like, I can't figure this out. There's no sample size, and then I realized, oh, this is like the old z-score.
Yeah.
Right. So,
Sample
yeah,
size.
that's, I realized it's that word sample that you're looking for again to know whether you
Yes.
have to put the
Keywords. Okay.
yeah.
Sample.
I know because it makes sense when you're doing it each week, but then when you put it all together,
Yes, gets more confusing.
it gets more confusing to know what it is they're looking for and how to find it. Because I realized that there's a couple of different times that I was like, wait, what? How? Like the formula, when it's just the sigma over the square root of the
Yeah.
n of the sample or whatever, and I was like, I'd forgotten about that formula.
Yeah, that's I call that the old z-score because that was the first one we learned.
Right.
So, okay, so moving on. Everyone's good with 6 then?
Yeah.
Number 7, someone else want to take over? I don't
I'll go ahead and do it.
keep
A
going.
sample size of 4 is taken from the normally distributed 2011 sales data. What is the probability that the X bar is greater than 35 and less than 55? So I just did the z-score formula for both of those and found that the 35 was -2 and the 55 was +2. So you plug that in the applet and you take the area between those two, so just the center section, and I got 0.9545.
Yeah.
Right. That one confused me though because I thought that they might have been looking for like I was still confused because it's just one standard deviation away because the standard deviation was 10. So I guess that just confused me because I was thinking of like the 68, 95.
Oh. Yeah.
So I was like, oh, because I just thought, you know what I mean? I don't know. It just made me confused because I thought that's what they were looking for because it was like 45, 35, 55. It was standard deviation of 10. It seemed pretty cut and dry that they were looking for that it was like
The
68%.
Yeah. Yeah. I don't know.
So I'm still confused as to like the -2 and 2, why it's -2 and 2 when it's just one standard deviation away. Like I was like, all right, unless it asks for the 68, 95, just go with the formula.
Yeah.
I think so.
I don't know. I think on the homework quiz, there's one. On the homework assignment, prep assignment, there's one that asks that.
Yeah, there was.
So.
But they ask for it. So I guess as long as if they ask for it in that form, then that's where you go, I guess. You just have to wait for them to ask for it in that form.
I think, too, it depends on what information you're given and if you can figure it out through the equation or if you have to draw it out. Usually if you have to draw it out, it's within that 68, 95, 97 point whatever rule. But if you have to go to the calculations, then they're looking for something more specific.
Right.
I don't know. I think 8 is just the exact same. I just got the exact same.
Yeah.
Yeah. It was just different numbers, different square root of 25.
I think they were trying to confuse you and make sure that you're paying attention to the greater than and less than, as opposed to like between. All right. Give me a minute, guys.
Baby.
Go ahead, keep going.
So then we're moving on to number 9.
A sample size of n equals 25 is taken from a normally distributed 2011 sales data. What is the probability that the observed x bar is greater than 50? So on this, I just did the standard equation the new equation that we were given to find using the sample size, which is z equals x minus mu over sigma divided by the square root of n. And so I just plugged the numbers in, and I got 50 minus 45 over 10 divided by the square root of 25, which is 2.5. And that's the z-score. And so then I took that z-score and put it into the normal whatever applet, and I got 0.0062 as a p-value.
Yeah, looks good.
Yep.
And I asked him that on the, he hasn't answered the question yet, because when he listed all the things on his little video of like what you can use, he didn't list the applet. And I was like, I assumed that
he did answer that. I saw it, and he said yes,
Yeah,
the applet is in play too.
I assume if you can use SPSS, you can use, or Excel, you can use an applet.
Yeah.
Right. It just, you know what I mean? He was like very specific about like you can use this, you can use this, you can use this, but you can't use anything else. I was like, well, you didn't say the applet, which is like part of our assignment, but I assume you mean that. Oh, he did answer. Last time I looked, he hadn't answered it yet.
He answered.
Okay, perfect. I figured he would.
Okay.
All right. We're on 10.
Yeah, I'll read the little paragraph. Pair Computing sold an average of mu equals 40 p-phones per minute in 2010 with a standard deviation of sigma equals 12. And they looked at their p-phone sales data and determined that the distribution is right skewed. Okay, so go ahead, number 10.
I can read 10. Samples of the size n equals 4 are taken from the right skewed 2010 p-phone sales data. What is the shape of the distribution of x bar? So it's right skewed since it's a small sample of a right skewed distribution.
Right.
And then I can do 11 too. The sample size n equals 40 are taken from the right skewed 2010 p-phone sales data. What is the shape of the distribution? And it's normal because the sample size was over 30.
Right. That's one concept I think I finally I got that one. Okay, number 12. Is there a theorem that justifies your answer to question 11? What is the name of the theorem? And that is the central limit theorem. Because it's that one gets confusing because you think you want to say the large number, but it's not. It's the central limit.
Because of the word shape.
Oh, that's right. Yes. Shape.
Yes.
I like that. Yeah.
I love it.
All right,
So
I'll
I'll
do
go
13.
ahead. Oh, you've got it. Go ahead, Sarah.
a sample size of 4 is taken from the right skewed 2010 phone sales data, and you want to know the probability that the observed X bar is less than 35. Can you compute this probability using the normal probability applet with the information you have? Why? No, you can't, because it's not a normal the distribution isn't normal, and you can only use the applet if our data is normal.
Right.
Right.
Working too, if you want. A sample size of 36 is taken from the right skewed 2010 sales data. What is the probability that the observed X is greater than 36.5? So we just plug our numbers in, 36.5 in, and we put it in the applet, and you have to remember greater than, so all the shaded area greater than that number, which was what, negative 0.8333, and I got, or no, sorry, 1.75, negative 1.75, and I got the probability to be 0.9599. Is that right?
Same here. Yep.
Mm-hmm.
I'll take the last one. The sample size of N36 is taken from the right skewed 2010 P-phone sales data. What is the probability that the observed X bar is between 37.5 and 42.5? And so with this one, I just plugged it into the equation with the sample, but I don't know what you call that. The second equation, is that what you're calling it?
They still
Heather?
call it a z-score, right? It's still a z-score,
Yeah.
but
It's a z-score, but it has the square root with the
Right.
with the
Let's go for
number.
a sample.
Sample
Yeah.
number.
And the
Yeah, so I
sample.
plugged it into that, and I just took one value, and I used 36. Let's see, what did I do? Anyway, am I looking at the wrong one? I'm looking at, what number is this? 15. So
Yeah.
the numbers are the same, but then I just realized, I think it was like a couple deviations away. So I don't remember how I got this one, but I think I subtracted it.
Well,
Yeah,
I think,
I don't
don't
remember.
you just put the two scores you got? So one was negative 1.25 and the other was 1.25. So you just plug that in the applet, and it wants the area between. So you just make sure that the area is shaded between those. That's your probability, which was 0.7887, I believe.
yep.
Yeah, I got all messed up on the 7887. I don't have my notes on it, but somehow I got the answer. So
It's just like number 7, right? Where it
Yeah.
was you subtract and there was -2 and then +2.
Uh-huh.
So it's similar to number 7.
okay.
Right, this time they just said between, and the other time they said greater than and less than.
Which is the same.
It's the same. It's just
Yeah, 'cause
worded
it's
differently. They're
just
trying to
worded
confuse you that you don't go the
different. Yeah.
other direction.
Yeah.
But pay
Oh, I know
attention,
what I did.
because they could say something like,
Oh, right.
It could be,
I mean,
it
they
could
could
be
say,
less than the negative number and more than the positive number, and then
yeah,
it's the two
Yeah.
outside.
so just pay attention to the wording.
And which
I
numbers
found
are
it.
asked for, because that's I feel like that's what they were trying to confuse us to do on that one. And then
Yes.
if you read it, it's greater than the smaller number and less than the bigger number, which is actually between.
Right.
I ended up accidentally doing 15 before I did 14, and so I got them switched around on my answer.
Yeah.
Got it.
Okay.
Okay, well, so did everyone go ahead and work on the group quiz?
I
Yes.
did.
Okay, I did too, but I was nervous about. I mean, I wasn't going to submit it anyways without you guys, but I'm like, oh, I'm glad we get to go over this together.
There was a few that I didn't want to do without you guys. So.
I did them all. I don't know if they're right.
Okay.
Number
well,
4.
I mean,
I
sometimes
was
I guess it's good if we all do it separately and then we go
Yeah.
over, because then we can figure out, instead of doing it together, we know whether we've if we've all got the same thing, then we're probably on the right track.
Right.
Mhm.
Thank you.
all right. You guys already have it open, or
Yeah.
I'm working on it.
so number 1 and 2. Oh wait, let me find my notes. Okay. Okay, number 3, I had a question. Is it worded wrong, or maybe you guys can help me out? Let me read it out loud so I can figure out what I messed up. Use the normal probability applet to find the combined area under the standard normal curve that is to the right of z equals 1.358 and to the left of z equals negative 1.358. Is that backwards?
No, they're asking for the outside numbers, I think.
Oh,
But if it's the same, if you plug the number in, they're both going to be the same. And so if you highlight the area outside, then it should give you the area.
Or you can just highlight one area and multiply it by 2.
Right.
Okay, then I was just reading that wrong. I'm like, wait, it's supposed to be in between. It's to the left of the
That's what I was
positive
talking about on the other assignment. They're like, you really have to pay attention to what they're wanting you to highlight.
Okay, so it's asking for the outside, but find the combined area under the. Okay, so what's on the left and what's on the right?
Right.
Add that together. Okay, okay. All right. Well, thank you for clarifying that because I was not understanding that. So,
and did you guys get
yeah,
0.175 on that?
Yes.
I didn't. I got 0.892.
Go and plug 1.358 in your applet and make sure it's just shaded on the left and the right, and it should be 0.17 like 4 or something, so which equals 0.175.
Let me find where I did the
my applet up.
group meeting. So let me find it.
So what were the numbers
1.358
on each side? Like negative?
Yeah.
It's negative and positive, yeah.
Yeah.
Okay.
You can't do that if the numbers are different, but if the numbers are the same, then you can do it.
Right.
So then the area at the top, 0.1745, is that the right answer?
Yeah, so 0.175.
Okay, 0.175. Okay, thank you. I mean, I can go back and do the math, but that would take me a few minutes, so. Here's my quiz.
Looks good. I just must have typed something in wrong.
It happens all the time.
Yes, it does.
Oh, number 4. Oh, I see I left number 4 blank. I was doing this late last night. I think I thought, oh, that's too many words. I'm going to go over that again tomorrow, and I forgot to come back to it.
I'll take that one if you want.
Okay, great.
The United States Coast Guard assumes the mean weight of passengers in commercial boats is 185 pounds. The previous value was lower, but was raised after a tragic boating accident. The standard deviation of passenger weights is 26.7 pounds. The weights of a random sample of 48 commercial boat passengers were recorded. The sample mean was determined to be 177.6 pounds. Find the probability that a random sample of passengers will have a weight that is as extreme or more extreme, I mean, it's either above or below the mean, than the observed that was observed in the sample. So round. And then there was a note, as extreme or more extreme means that we are not only interested in the values that are lower than the ones we observed, but also the values that are far away from our mean as ours in the positive direction. So I took that to mean like the last question, the ones on the left and the ones on the right.
Okay.
Okay.
So for this one, I just plugged it into that z-score. So you took the weight they gave us with the x, which was 177.6 minus 185, the mean they gave us, and then just divided that by the standard deviation, which was 26.7, divided by the sample size, which was what, 48. And I got negative 1.920. And I just threw that in the applet and then took the area on both sides. And my answer I got was 0.055. I don't know if anybody else did that one.
In one of the bins out there. So I was confused. I was confused by the wording. Like I got negative 1.92 also.
Okay.
But I am confused by what they're asking. Like all those words at the end, like Heather said, I was like, there's too many. Back to my too many words. Too many words. Like I'm not sure.
Yeah, when I read the note again, as extreme or more extreme means we are not only interested in the values that are lower, but also the values that are far away. So in the positive direction. So I just thought it meant the ones that were below that number and the ones that were above. So we don't have the middle of our applet shaded, just the ones on the left and the right.
It does sound a lot like number 3.
Yeah, I don't know if that makes sense to you guys or if that's the same conclusion you can draw from that.
So
Well,
your
'cause
p-value
the question though, the question says find the probability that a random sample of passengers will have a weight that is as extreme or more extreme than the observed in the sample. So why would they want less? Like that's why I have a hard time thinking that they would want on the left side.
I don't know. I'm just going off of what the note says.
Yeah,
So
no, because I know what you're saying. I understand what
Yeah.
you're saying, but like, because I read it a few times trying to figure out but when I read that one, it says as extreme or more extreme. It says either above or below the mean. So the mean is going to be your center point. It doesn't mean that it's like to the left of your. I don't know. Like that was what confused me. I
understand what you're saying. I don't know why they use that wording or why that wording means what they're saying it means. I don't even
I don't know why they put so many words. I feel like they
Right.
put too many words that made it confusing because they said the same thing a couple of different times in a couple of different ways.
Right.
Because I took that as everything above negative 1.92.
Lower than the ones we drew.
So what did you guys get for your z-score? Can I back up and...
Yeah, we got negative 1.920.
Why did I not get that? Because I forgot the decimal point. Ah!
Yes, that'll do it.
Okay, well let's maybe take the answer that you got and the answer that I got and put it into like the concept and see which makes sense. Does that?
Yeah.
Because like mine was 97%, 0.97. Like does
Mhm.
that even make sense? I guess.
Let's see.
And what did you get, Sarah? Was
I
that
got 0.055.
okay?
So those are like two different extremes.
Yeah.
Tell me what your z-score... Did you guys both get the same z-scores?
Yeah.
Yes.
Tell me one last time. I'm sorry.
Negative 1.920.
Okay, I got that.
And when you plug that into the applet, if you take everything on the left and everything on the right, you get Sarah's answer, 0.055. And then, Corey, what were you? You were.
I did everything to the right of negative 1.92, so I did the middle and the right section.
And left out the left section.
Yeah.
And got 0.97.
73. Which seems high. Let me do that. I'm going to plug it in again.
I just did it. It's not 0.9726.
Okay. Because it said because it used mean like in this that's why I did that because it said more or less than the mean, either above or below the mean, and the mean is the midpoint, but that doesn't mean like everything to the left of that number.
All right, I see what you're saying here. I'm reading it again.
But also the values that are as far away from the mean as ours in the positive direction. So that's all the way over to the right. As extreme or more means, or as extreme or more extreme means that we are not only interested in values that are lower.
Far away from the mean as ours in the positive direction. I guess is what I read. So it's like as far away in the positive direction, but it didn't say in the negative direction. I don't know. But my number seemed high, seemed really like 97% seems high.
Does anybody have our teacher on speed dial? He said we can contact him.
He did say we could call him.
I don't know if I would call him, but maybe text him and say, hey, can you help us with number 4? Like, are you available?
I can text the TA.
All right.
And maybe while we're waiting to hear back from them, we can move on to our other stuff before we...
Yeah, that sounds good.
Are you going to do that then?
I'm in the meeting. Yeah, I'll text both of them.
Cool,
Okay.
thank you.
I haven't done that yet. I've only emailed him, so...
Me
I
too.
could email him, but...
I got a new phone. I don't know how to do a multiple message, so... Okay. So what do I say? Stuck on number 4? What should I ask him?
Quiz, yeah.
Group quiz. Are you available to help us? And then maybe call and talk. I don't know.
Yeah, we just need them to explain what they're asking, I think.
Yeah,
Like,
because we understand what to do, we just don't know what they're asking.
what they're asking for. Mhm.
Yeah.
Okay. What they are asking, we are not sure what they're asking. We have numbers that we feel good about.
Yeah, so we have the z-score, we just don't know how to interpret the data from the applet. Like what data to take.
Okay. Okay. You guys don't have to stare at me. You can go ahead.
I'm reading the question in my head again.
I know. I'm not staring at anybody except for the question.
Mom.
But when you're done with your text, we can move on.
Okay. Hold on. I'm going to just forward the same message on to Emily. Okay. Done. Now we just have to wait.
Let's wait and see if we hear back from one of them. So we can move on to number 5.
Okay, as I was reading that again, okay, never mind. Let's just move on.
Oh, if you thought of something, share.
No, like Sarah's, when you plug the numbers back in, Sarah's answer makes more sense because it says the sample mean you got was 177.6 pounds, and the original mean they were saying was like 185. And they're saying what is the likelihood that the weight is as extreme or more extreme than was observed in the sample? Just let's see what he has to say.
Like the more you read it, the worse it gets.
Yes.
Yes, exactly. Okay, on number 5, which of the following will
Shut
have
the
a
door.
smaller
Phoebe, shut the door.
standard deviation if 9 observations are randomly drawn from the population? So that one,
This one was like another language to me. Like I
right?
could not.
I skipped it at first, but then when I thought about it, so which one will have a smaller standard deviation if 9 observations are drawn from a random population? So 9 is not a big. I don't know.
Okay.
I didn't answer this one.
I went back to chapter 6, to lesson 6, and I have written down that the mean of samples and means was always, okay, so if you took a sample larger than n equals 1, the standard deviation of the sample means was always smaller than the standard deviation. So we have 9 observations here, so we know that our standard deviation of the sample mean will be smaller than our regular standard deviation. So I took that to mean that, so what is the question? Which of the following will have a smaller standard deviation? And I put the distribution of the x-bar. Because the x-bar, that's the...
Sorry.
That's the new equation.
Oh my gosh. I'm gonna stop that. Oh my gosh. There, all right. Sorry, guys.
All right, so that's fine. I just took that to mean the distribution of the sample means, which is the second one, I guess, the middle one with the x-bar, because that is the... Oh, I lost my train of thought.
That's what I wrote down. So I skipped it at first and I read it later, and that's what I wrote down after I had like saved for later on my test, so I wasn't working on it.
Yeah.
But I don't know why.
I didn't dig very deep. I just thought there was not enough information because it doesn't say normal population. I don't know. That was all I could get out of it.
My cue was they tell us that there's 9 observations, and that one thing says if the sample size is larger than n equals 1, then the standard deviation of the sample means will always be smaller than the standard deviation.
Oh.
And
You found that in chapter 6?
yes.
What section?
Let me go back and find it. I just have it written in my notes. Just a sec.
Well, and it was like, isn't that like, that's like the sample size, like the law of large numbers, right? Like the bigger your sample gets, the smaller your means.
That's what I was thinking. That's why.
That's why I did that one, because that's what I was thinking. But it's not
they
a
get
large
closer
sample.
together, so it gets smaller.
Right. The bigger and bigger your sample gets, the bigger your sample gets, the closer your mean gets toward, the smaller your standard deviation.
Right, because they start to line up.
Mm-hmm. So a sample mean would have a smaller distribution than an individual observation would.
Okay.
Okay, I found the section, Lee, if you want to know. It's underneath section 4, mean and standard deviation of the distribution of sample means. And it's the last sentence in that.
So 6.4?
Sorry. No, it's just if you go down, number 3 is the central limit theorem. 4 is mean and standard deviation of the distribution of sample means. It's towards the bottom.
I know, but what are the numbers, like the reference points? The 6 point something point something?
It's 4.
Oh, 4 point what?
Just 4. There isn't any points on that one.
Oh, okay. Thank you.
Yeah.
And that's in chapter 6?
Yeah.
Okay. Dieter has to help you. I can't. I'm in the meeting.
Okay, so are we feeling...
I feel good about maybe the next one, but... which of the following results implies that the spread of X bar decreases as the sample size increases? And I don't know, this one I did, it's either the central, spread. Oh, what's the word?
There you go, use your words.
Hold on, don't tell me, you got this. Spread is going to be the central limit theorem.
No.
Nope.
What? No.
That one's shape.
Yeah.
Did I write it backwards? So close, accurate. I transcribed them to another sheet, so my cheat sheet, and I don't want my cheat sheet to be wrong. So the CLT is shape and approximation.
Mm-hmm.
Oh, I got them backwards. Okay. So as I had it originally marked law. I just want you to know, I had it originally marked law of numbers on at first, but then I wrote my notes all wrong. I'm having a write my notes all over the wrong place day today.
Fix your note right now so you don't forget.
I am. So the CLT is shape and approximation, and law of large numbers is close accuracy or spread. Was there any other words for CLT besides shape and...
I only looked for shape. I didn't even think of approximation.
So, or approximately. Okay. Sorry. I'll take the next one because I've kind of hosed you guys on all the ones that I've done so far today. It's a good day. Scores of the quantitative portion of the GRE are approximately normally distributed with the mean of 150.8, the standard deviation of 8.8. Use this information to answer the questions 7 through 10. So number 1, Diane earned a score of 160 on the quantitative portion of the GRE. What is the Z-score corresponding to Diane's score? Round your answer to 3 decimal places. Example, blah, blah, blah. So for this one, I just plugged it into the normal Z-score without the sampling option. So it was just 160 minus 150.8 divided by 8.8. And I got 1.045.
Yeah, me too.
Oh, I got 1.046. I better do my math again. I might have just been off.
Phoebe, get a baby bagel.
1.045. Okay. Oh,
good.
Got that one. Okay. Number 8. What is the probability that a randomly selected student will score above 160 on the quantitative portion of the GRE? So again, what did I write? It was the same numbers, right? But just changing the applet?
Yeah.
But of course I had 1.046 written down, so that might be different.
Well, I think they're asking for the Z-score in 7, so you use 7 Z-score for 8 to find the probability.
Oh, okay. That's why I said applet above. I didn't say that.
Yeah, so use the 1.045.
Okay. And then I came up with 0.148, but now I'm wondering if it's different because I had the wrong one.
That's what I got too.
That's what I got.
Okay.
I'll take 9 if you want.
Okay.
A random sample of 5 students was selected to take the GRE. Their scores are those. What is the z-score corresponding to the sample means of these students' scores? So I just put, first of all, you had to find the mean of those 5 scores. Did you guys do that first?
Yes.
Mhm.
Add them all
I
up and then
didn't. I thought those numbers were just in there to make me mad. I was in bed at like 3 o'clock in the morning, so I obviously need to get some sleep.
So I found the sample mean from those. I added those all up and divided by 5, and I got my mean to be 160. Did you guys
Yeah.
get that too? Okay. And then the z-score, I just plugged all the stuff in, right?
Right, and
Yeah.
this time because it's a sample, you have to do the z-score with the
Standard
square root of 5.
divided by the square root. Yeah.
Right.
So I think that's what they're testing you on is you're using the same numbers, but on that one you have to use your sample,
Uh-huh.
and the one before you're doing just an individual or parent population or whatever they call that.
Right. So did you guys get your z-score to be 1.15? Is that?
No.
No. All right. I don't know where my notes are on this one. So what did you guys get?
So our mean was 160
Right.
minus 150.8.
Mm-hmm.
Is that right?
Yeah.
Yeah.
Oh, I'm like, what are the 150.8? Divided by 8.8 divided by the square root of 5.
Mm-hmm.
And I got 2.338.
Yeah,
That's
I got
what I got.
2.3. I put 2.3377 just because
Yes.
extra
I
numbers.
did, but
Yeah.
then changed it. Does it say? Yeah. It says
They
that.
asked for 4.
This one asks for 3 decimal places.
Oh, you're right. It does say 3. Oh my goodness, I need to.
I have
So
my
on the
notes.
next one asked for 4.
Oh,
The
yeah.
The reason why I didn't add them all up is because it's going to be, remember when we dropped all those boxes down and eventually it's going to be the same, it's going to be the standard, it's the same, the standard, the mean of the whatever is the same as the mean of the whatever, so it doesn't matter. The mean is still 160. You know how they ask us these questions and they're like, find the mean, and it's the exact same number, but it's like,
Right.
it's mu x, or is it mu x bar equals mu equals the mean?
Yeah. No, I know what you're saying.
Anyway, so that's why I was like, I don't have to add it up because it doesn't matter. You're going to get the same, because it's from the same sample set, so you're just going to get the same mean. Anyway, just
I understand what you're saying, but the other one before is just a single person. It's just Diane earned the score of 160. She could have earned the score of like 182. That wasn't an actual mean that you're working with on that other problem. Does that make sense? Because the mean that they had before was 150.8.
0.8.
And then when we took with that random sampling, the mean was 160. So you had to subtract the 160, which was the mean from our sample, from the standard mean.
So I just got lucky in thinking that.
Yes.
Yeah.
Well, that's really nice of the Lord. Okay.
So what was the answer you guys got?
2.338.
Yeah.
Okay.
2.338.
Lee, if they ever give you a list of numbers and ask you for the mean, please add them up and divide them by that number.
Thank you, I will. I obviously haven't had my Diet Coke this morning.
Right. But yeah, I wouldn't shoot for maybe hoping that it's the same.
Okay. Yeah. I was just trying to help you understand why you should do it more. Sometimes it takes us making the mistakes so that we can understand why.
Yes.
I was taking a lamb to the slaughter for you.
There you go. Well, that's why we did this as a group, right?
All right.
Yes.
I have number 10, but then I just decided let's see. I have number 10. Oh, and then I'll just do number 10. What is the probability that the 5 random selected students will have the mean score that is greater than the mean achieved by the students in the previous problem? Now, I'm really on a roll today, so I don't know what it's going to be. I got 0.0097, and that's just because I put that z-score into the applet, and I made sure that I highlighted the greater than side.
Yep.
Hey,
Sounds right.
I'm crazy because I got number 9 wrong, but I had number 10 right, so who knows what I did.
And I'm confused because I don't know, on my paper I have 0.097, but then I also have 1.035. I don't know where I got that number from, or what it was, or what it means. And that's what I'd put in as my answer.
Well, I think
Just
it's
yeah,
0.0097.
Yeah, throw it in your applet again and just double check, but that's what I got too, 0.0097.
So you put sorry, what is the probability that 5 random students will have a mean score that is greater than the mean achieved? So we just have to do, in the applet you highlight the more than side, right?
Yeah.
And then just put in the 0, or then we just put in that 2.337, is that?
2.338.
2.3.
I felt like I got.
Okay, yeah, no, I have 0.0097. I just don't know why. What else I did? Like on mine had like negative 0.0097 over something else. I don't know what I did. I don't know what I did. It seems like I did something else after that, and I don't know why. Like it was late, so.
Extra steps.
I feel like I got, after practicing and doing these over and over and over again, I got it. But then as soon as they threw in that stupid null hypothesis and alternative hypothesis, reject or true thing, I was totally like, I have no idea. Like
because it was going back to the p-value that was all confusing from the very beginning.
Yes, yes. I was thrilled we haven't had any of those questions, but I'm slightly terrified on the homework that something's going to come up like that on the quiz.
It wasn't, but it actually, I did the homework, and it started making it make sense. It was actually, like, I said that to my husband at the end of the night, last night when I was finally done. I was like, oh my gosh, I think I might finally be understanding, like, the p-value, because the p-value is all about, like, this probability. They've just been, like, talking about probability for the last few weeks, and then they're like, okay, now here's a real problem, and this is what you're working on. It actually seems like it makes more sense when you start plugging it into actual math problems. I almost felt like I saw a little light associated with p-value. So, okay, so we're going with 0.0097 on that one.
Yeah.
I don't know. Yeah, I had that number written on my paper. I don't know what the other number, where the other number came from, or what I was doing to get it. So.
All right. Well, suppose the mean GPA of a BYU Idaho student is 3.5 and the standard deviation is 0.7. It is well known that the distribution is left skewed. A random sample of 81 students will be drawn. Use this information. The shape of the sampling distribution of the random variable x bar, which represents the sample mean of the 81 students who are selected. What is the shape? So I put approximately normal because it was 81 students that they took the sample from, which is greater than 30.
Yeah, me too.
And that's where that approximately comes in, right? You were talking about it before? Because it was left skewed, so it's not normal, it's approximately normal.
Yeah. Yeah, because it has to do with the sample size. So.
Yeah. Yep.
I'll do number 12. What is the mean of the distribution of the sample means, sampling distribution, for all possible samples of size 81 that could be drawn from the parent population? So, wait a minute. I don't have any notes on this one. Does that mean the answer was right there in the question?
Yeah. Remember, we know that the sample means is going to equal our
3.5.
Yeah.
Okay. I'm like, why don't I have notes? I didn't need notes for that one. Okay. So 3.5.
I'll take the next one. What is the standard deviation of the sampling distribution of the random variable x bar, the mean of 81 students who are selected? So this one, we're just going back to finding the regular old standard deviation, right? So it's just 0.7 divided by square root of 81, and I got 0.078.
Yeah, 0.778.
It wants 3 decimal points, so
Oh yeah, 0.78. I wrote it wrong.
Yeah.
What did you guys get for 12? I'm sorry, I was...
3.5. The answer
Okay,
was
that's what I-
up in the problem, the question.
Right, okay, I didn't even read it. I was just, I was distracted for a second there. Okay, that's what I had written down.
13 was 0.078.
Yes. Okay. 14. Why do I not have 15 written down? Did I not get to 15? 14. I can read 14. What is the probability that the mean GPA for 81 randomly selected BYU Idaho students will be less than 3.3? Let me see. So you do the 3.3 minus 3.5 divided by 0.7 divided by the square root of 81.
Yeah.
Okay, and I got negative 2.577.
I got negative 2.5714.
me too.
Oh,
All right.
you know what? Oh, this one. What did you? I got negative 2.571.
Me too.
That's
Yeah,
what they.
that's
That's
what
what
I
I did something wrong
But-
somewhere.
That's not the answer that I put in number 14.
That's a z-score. They're
Oh,
looking
it's
for
not.
a probability.
We have to put it in and then find the less than.
Okay.
Oh, you know, because I used when I did it, I used four digits. Maybe that was why. From the 0.7 divided by square root of 81, I only used 4 digits, so maybe that's why our mine is different. And then you plug it in, and you end up with is it 0.010? Is that how you round that?
I got 0.005.
Me
That's
too.
what I got.
Okay, because I had 0.00. See, because that's right, because mine was different from the 4. I had 0097. I was like, what do you do with 97 to round to 3? So yours makes more sense, anyways.
Yeah, just make sure in the applet you're doing the negative and then less than that.
Yeah,
Just a
I
very
I use. I think it has to do with the number of decimals I used, but that's
All right.
crazy how much difference that makes in the answer. Okay, so 0.005 is what you guys ended up with as a total answer.
And 15's the same. We're just trying to find out what was greater than 3.3. So just shade everything else besides that lesser part.
Or
And-
subtract it from 1.
Yeah, that's true. So you get 0.995, correct?
Yeah.
I did.
Okay.
Okay.
So, Lee, did anybody text you back on number 4?
No.
Mm,
Let me see. Hold on. No. Nobody has responded.
darn it.
Yeah.
So we have to decide. Well, do you guys want to hang out and go through the homework together and come back to this information, or do you guys not have time?
I have to get my kid to the doctor again because he's got new symptoms.
Oh, no.
Yeah, it's killing me.
I have time, but how much time do you have, Sarah? Are you done?
I have a few more minutes, but we can always stop broadcasting. We don't have to turn in our homework yet until we hear from everyone or from our teacher. When you hear from Lee, maybe you can just send us an email or whatever, and then we can turn our homework in later. Does that work?
You need the group quiz?
Yeah, that group quiz. Yeah.
Yeah,
I've got until I'm headed out of town at 2 o'clock. So
Okay.
if you don't hear from, I'll shoot you out an email before I leave and let you know if I heard anything. So I mean, I guess I could always check my email on my phone, but it's stupid.
That's fine.
iLearn.
We can text him too. Do we want to quickly go over our answers to make sure we have all the same besides that one?
Yeah.
All right. So for number 3, we all have 0.175.
Mm-hmm.
Don't know about 4. 5, we picked the distribution of the sample means x bar, correct?
Mm-hmm.
6, the law of large numbers.
Yep.
7, 1.045, 8.125.
Wait.
No.
No.
1.148.
Thank you.
Yeah.
I don't know what happened there.
Can we go back up to 4 and give the 2 separate options so that if they do, I've learned that with him, if you give him all these different options and you show that you've done the work.
Yeah.
So I just wanted to get the 2 options that we came up with. I think one of them was negative 1.920 or negative 1.9. Yeah, right.
My number 4, I got 0.055.
Oh, right. 0.05. The 1.920 was the z-score. So the p-value was 0.055. And this was Sarah's. And then, Corey, what was yours?
0.973. So like complete opposite. It's like 5% or 97%.
Right.
Okay.
But
Okay.
you can also tell them that we got our z-score to be negative
Yeah,
1.
say we've got the z-score. We're just having problems with the applet. And
Yeah.
Right. So what I'm going to say is that the p-value of Sarah's is the 2 values that are highlighted on the very ends of the bell curve, and then Corey's is from the mean to the and greater than.
From whatever our negative number, whatever the number was that we got before, the negative.
Oh, okay.
From
The negative
our
1.9.
z-score, the negative z positive, yeah.
Okay, got it. Okay, thank you. I just wanted to clarify.
No, that's good.
Thank you for doing that.
And I'm glad we went over this because for number 8, I had the right answer written down. I don't know why it was wrong on here. So 9, 2.338, 10, 0.0097, 11, approximately normal, 12, 3.5, 13, 0.078, 14.005, and 15.995.
Can you read 9 and 10 again? I was just making notes on number 4.
Yeah. 9 was 2.338, and 10 is 0.0097.
Right.
All right.
And then we're going to wait.
Later and have to remember to come back.
Yeah.
Yeah. Oh, we'll wait. We'll give them some time. So.
All right.
Emily is usually really good to get back with me. If she's in class, she won't answer her phone, but as soon as she gets out of class, she'll respond. Most of the time. So are you headed out, Sarah? And we'll.
I have a few minutes.
Wait, he's right here.
Oh, good.
Hello. Hello. Hi.
Hi.
I have you on speakerphone, and we're in the middle of our meeting at this time. So.
Okay. I can't join you in your meeting, but I can talk to you on the phone.
Okay, perfect. So we're taking the quiz all together. All of us are here, and we're at number 4, the United States Coast Guard question, and it's like a lot of words. I can read them all to you if you want. Do you want me to read it to you?
Yeah, is this on lesson 7?
It is lesson 7. Yeah.
Okay.
Number 4 on the group quiz.
Okay.
So the United States Coast Guard assumes the mean weight of passengers in commercial boats is 185 pounds. The previous value was lower, but raised after a tragic boating accident. The standard deviation of...
Hang on, stop right there.
Okay.
So you've read 2 sentences. Now, first sentence, what does that really say?
That is invalid because they've changed it since then.
That was the second sentence, it sounds like.
The previous value was lower, but raised after the tragic boating accident.
Okay, so that's interesting, but who cares, right?
Yeah.
Mm-hmm.
So 185 doesn't mean anything.
No, 185 is the mean.
That's the first sentence. What does the first
Oh,
sentence say?
it is the mean. Yes, we have that down as the mean. Got it.
Okay.
As the mu. Yeah. Okay, the standard deviation of passengers weighs 26.7 pounds, so we wrote that as the standard deviation. The weights...
Sigma.
Yes. The weights of the random sample of 48 commercial boat passengers were recorded. So we have 48 as the N, as the value, or the number. The sample mean was determined to be 177.6 pounds.
Okay.
So I'm not sure. Oh, that's the X bar. That's the X bar. Find the probability that a random sample of passengers will have a weight that is as extreme or more extreme.
Okay. What does that mean? As extreme or more extreme?
That's what we're having a hard time with. We all got the same Z-score, but then we had a difference of opinion of which sections of the normal probability applet to highlight.
Okay. So what is your Z-score?
The Z-score was negative 1.920.
Okay.
And one suggestion.
What areas to highlight? Give me your arguments.
Okay, so one suggestion was to highlight, because one was that it's the two extremes, the one that is extreme or more extreme, and so to highlight the very left and the very right of the bell shape, which gave us a p-value of 0.055. And then the other one was because of the note, it says as extreme or more extreme means that are not only interested in the value. How, Corey, tell me how you would say that again.
I did it from the negative 1.92 positive from that. So Corey highlighted from the Z-score and greater than. But the reason why she felt like that was because, that's what I want you to say, because I can't remember the wording that you chose. I don't remember.
But also the value is as far away from the mean, So I think you felt that if we highlighted, in a positive direction, because I think you felt like if we went on the other side, we were still staying close to the mean as well, but we had to get as far away from it as we could. So. But start from the mean and move forward, or start from the Z-score and move forward. So, which gave us the answer of 0.973.
Okay.
So we're wondering if you can help us understand exactly what they're asking for.
Yes, I can. If the question was said, what is the probability of a mean being less than 177 point whatever it was, then you would highlight only the left tail, because you're going to have a negative Z-score, and you would highlight only the left tail if it said less than. If the question said, what is the probability of it being greater than 177, well, your Z-score is still going to be negative 1.92 or whatever you said it was. But the greater than means I would highlight everything to the right of that Z-score, which would mean both the center portion and the right tail.
So that would be the 0.973 portion.
Mm-hmm.
Correct.
Yeah.
If it says as extreme or more extreme, what it's saying is, tell me what's the probability of Z being less than negative 1.92 and greater than, well, not and, I guess that's an or greater than 1.92. So in that case, you would highlight both the left tail and the right tail and leave the center portion blank.
So
statistically speaking, as extreme or more extreme means if it's negative, equal to or lower than on the negative side, plus whatever is equal to or greater than on the positive side, same distance from the mean. So that's just a long way of saying what your first proposal was the correct interpretation.
Okay. Did you guys hear that?
Yeah.
Yes.
Yeah, thank you.
That's great.
Okay. Thank you so much. That was the only one we really had a question on. So.
Okay, I'm expecting 100% then.
Okay. Thank you so much for getting back to us. Have a good weekend.
Yeah. Okay, see you later.
Okay, bye-bye.
Bye.
Does that help?
Yes.
Yeah.
So now we know as extreme and more extreme means the tail ends.
I wish I would have asked him about 5, because with my luck.
Okay, so what was the numbers on that one, Sarah? 0.005?
Yeah, 0.055.
0.055.
Yeah.
Okay. Okay. I know. Now that nobody asked any other questions, we should have asked it.
100%.
We got it. It's good.
Good job, guys.
Whew. I'm like pouring buckets of sweat over here,
For
man.
real.
Okay.
All right, I'm going to tap out now. I'll put this up as soon as it uploads, and you guys have a great weekend.
You too,
Thank
Sarah.
you.
Great.
Yeah.
Good luck with your sick kiddos.
Thank you. Okay, bye-bye.
Bye.